Hi, it's Miss Lanou again. So today we're going to be talking about multiplying and dividing rational expressions. A rational expression is basically anything that can be written as a fraction. So your rules that you've learned about fractions are going to be very similar when we're applying them to rational expressions. The first thing that's good to talk about here is simplifying rational expressions, and that's why I've started in your notes, so you can go back to it later. One property is that if we have an expression like a times c over b times c, we can cancel out those common factor of c on the top and c on the bottom, because anything divided by itself is always going to be 1. So that gives us the simplified expression a over b. So these are equivalent expressions here. If we try that with some real numbers, for example, if you have the fraction 15 over 65, we can represent 15 as 3 times 5, and 65 is 13 times 5. Now, if we cancel out those common factors of 5 on the top and 5 on the bottom, we're left with 3 over 13, which should be familiar to you if you remember how to simplify fractions. Where we can relate this to Algebra 2 is that if we have a factored expression, like 4 times the quantity x plus 3 over x minus 5 times x plus 3, we can still cancel out the common factor. So since x plus 3 is a factor of the top and x plus 3 is a factor in the bottom, this is equivalent to the expression 4 over x minus 5. Notice I can only cancel things out if they are factors, so only if something is a factor can it be canceled out. So if we're simplifying rational expressions, our steps are, first, we want to factor out the numerator and the denominator, that's the top and the bottom, and then we want to cancel out anything that's common on the top and the bottom, and that's how you simplify a rational expression. Okay, so let's look at some examples of where we might simplify a rational expression. The first one, we have 40x plus 20 over 10x plus 30. Now, if you're thinking that you can cancel out the 40 and the 10, if we can divide by 10, okay, that's a misconception. We can't do that because they are not factored yet. So first we want to factor both the top and the bottom. If we factor the top, okay, a number that goes into both 40 and 20 is 20. Okay, 20 times what gives us 40x? Well, that's 2x. And 20 times what gives us 20? That would be 1. So on the top we have 20 times 2x plus 1. And then on the bottom, if we factor out, let's see, they have a common factor of 10, we're left with x plus 3. Okay, so we have, this is our factored form. And if we look at 20 and 10, we can factor those further. 20 is actually just 2 times 10, so we can factor that. And we have 2x plus 1, and then we have 10 times x plus 3. Okay, so the common factor here, we have a 10 on the top, a 10 on the bottom. We cross both of those off. So we're left with 2 times 2x plus 1 over x plus 3. Okay, and we can leave it in this form. You don't have to multiply the 2 back through. I'll let you just leave it in this form like that. Okay, so that would be our correct answer. And it is simplified as far as possible because all 3 of these terms are factored as far as possible, and they don't have any common factors. There's nothing on the top that's on the bottom as well. Okay, let's try the next one. So we have 4 over x times x plus 2. Notice the top is factored, the bottom is factored. They don't have any common factors, so this is already simplified. Already simplified. Okay, there's nothing further to do. So let's move on to the next one. We have x plus 4 over x squared minus 16. Our top is factored already, so we're just going to rewrite that. Our bottom is the difference of 2 squares, right? Our a term is x, and our b term is 4. Okay, so we have x minus 4 times x plus 4 are our factors there. Notice that x plus 4 is on both the top and the bottom, so we're going to cancel that out. On the top, okay, if you've canceled everything out, then you're left with 1. Then on the bottom, we have x minus 4. And that's our final answer. Okay, let's look to the next problem. So we're going to, again, factor the top and the bottom. So we're looking for, on the top, we're looking for factors of negative 3 that add up to positive 2. Okay, so I want negative 3 and positive 1. So that's going to be x minus 3 times x plus 1. Okay, and you can go ahead and, if you need to check that, multiply it out. And then on the bottom, we're looking for factors of negative 6 that add up to negative 1. So we have negative 2 and positive 3. Oh, that would give us, if we add those, that gives us positive 1, so we need negative 3 and positive 2. That'll give us, those add up to negative 1. So we have x minus 3 times x plus 2 on the bottom. See how factoring is very, very important here. If you don't factor correctly, then you can't cancel out the correct terms. Okay, so now we have x minus 3 on both the top and the bottom. Those cancel out. My favorite part there is canceling them out. Okay, so we're left with x plus 1 on the top, x plus 2 on the bottom. And you can either keep the parentheses or erase the parentheses. It doesn't matter. Okay, I'm going to erase them because I like it without the parentheses, but either way they're the same thing. Okay, and that is our final answer. The final example here, we've got 2x squared plus 10x over 3x squared plus 16x plus 5. Notice how our top here, there's no c term. Okay, so this is a case where we can factor out just the x. So we have x, and then we're left with 2x plus 10. Because x times 2x gives you 2x squared, and x times 10 gives you 10x. Okay? And then in the denominator, this is where we're going to use our special factoring patterns. So you might want to do this off to the side. Sometimes I like to do these problems off to the side. So let's do, we've got 3x squared plus 16x plus 5. We're looking for, remember we have to multiply the 3 and the 5. So we are looking for, and I'm going to scroll over here so I've got some more room. Factors of 15 that add up to 16. Okay, and that would be 15 and 1. So we want to rewrite this, 3x squared plus 15x plus x plus 5. Split it into our two separate problems here. Okay, the common factor of these two is 3x. So we're left with x plus 5. And the common factor over here is just 1, because they don't have any other factors. And then we're left with x plus 5. So one of our factors is x plus 5, and the other one is 3x plus 1. So I'll rewrite that, 3x plus 1 times x plus 5. I'm going to go back over here and write x plus 5 times 3x plus 1. Okay, so we want to look at our problem again. It appears that there is nothing that cancels out, okay, but it looks like I accidentally forgot to factor this guy fully. Okay, 2x and 10. 2 and 10 actually have a factor of 2, so I didn't factor that completely. So let's start over. Apologize there. So I can factor out a 2 as well as the x. So I have 2x, and then I'm left over, I have x plus 5. So factoring all the way is very, very important there, otherwise some things might not cancel out. So I've got an x plus 5 on the top and the bottom. And then I'm going to cancel that out, so I have 2x over 3x plus 1. And that's the final answer.